And also, this is the current hot subject. If you go to chemistry or even physics, this professor, the Haruta, he invented or discovered the catalyst of gold. And actually, this is his first paper. And actually, I helped him to have this micrograph. And he had also had a hard time to convince the proposal. So big catalyst, the professor don't believe him. So, but these days, catalyst, gold is used to be a nice catalyst. But this is interesting. Okay. Then the carbon nanotube. This is single carbon nanotube. The multiple carbon nanotube reported in 1991, and this one, the single, 93. Then it is very rather interesting. I reported this, and many people, well, not so many people, some people saying, wait a minute, I discovered this first than you. And actually, a couple of years ago, the American Carbon Society made a detailed document who did it first. And the answer was if you can go back to the 1953 in Russia. The Russian already reported the carbon nanotube. But this is important, okay? If you look at only these pictures, micrograph, I can say the diameter is something like 1 or 2 nanometers. But we cannot tell anything about atomic structure inside. So to say this, you need a electron diffraction pattern or X-ray diffraction pattern. So if you analyze this diffraction pattern, then you can say this structure consisting of the graphitic structure, carbon hexagons, and the diameters. So without this, maybe this is carbon nanotube, but no direct evidence. So I think this is very, very important. Okay, so because no one showed this one previously. Anyway, so once you find interesting the structures, maybe you should have many evidence to convince the people, so that you will discover. Anyway, so then this is already knows how the carbon nanotube grow, depending on the single tube or multiple carbon nanotube. And this one is the single carbon nanotube. And we have this is catalyst. So depositing on substrate. So then we have the larger metal particle. Using this particle, we deposit the carbon. Then we have this nanotube. Sometimes we have the catalyst on top or at the bottom. And this is kind of direct evidence. So you have the metal particle at the bottom, and then you have a single nanotube. Diameter is close to determine this diameter of metal particles. So if you prepare the very small catalyst particle, then you may have the thinner tube. And so still many people working on this, because if you prepare the carbon nanotube, you have thicker one and the thinner one, some distribution diameter. So sometimes it's not good. So I have been working on this project. My approach is to use the mass spectrometer and mass separation. Okay. So these days, you can have the 10 or 10 or 100 atoms cluster. No other size. You can only select by mass spectral mass, the separation. So if you deposit this, then you should have only same diameter as shield. So this is very ambitious try, but still no one succeeded with it. So I have been working with this. Right, now they are using microscope, the latest microscope, you can get the detailed information. This one, the single carbon nanotube, and the single images give us all the information about the carbon nanotube, because almost we are able to see individual carbon atoms. Okay, so immediately we can tell this one is 18 all the tubes. And so this is very powerful technique. And not only the regular regions, but this part is somehow we have the crystalline defect. So you see pentagonal symmetries here, 1, 2, 3, 4, 5. Because this structure, carbon nanotube, consisting of the hexagonal carbon unit. So we shouldn't see this pentagonal. So something happened there. And then if you detail, then you can find the pentagons or heptagons. Others are the hexagon. So this kind of defect you can get from the microscope. This is very important. In the regular structure, you can use other diffraction technique, X-ray or neutron. But when you come to this the defect structures through microscopy, it's very important, very powerful. Okay, now I'm coming into the another subject. Okay, so we can put the carbon nanotube at the center. We have the empty space. So there we can put many things. This one is I believe this is the first report, and then the multiple carbon nanotube. We have this case lead or maybe lead carbonate. So we can fill the central part of carbon nanotube with some material. Yeah, this typical one. This is we put the iodine in a single carbon nanotube. So these dark dots are individual iodine atoms. So they are moving around. Then if you have the thicker one, then you have more iodine atoms. Interesting point is that iodine has the crystal structure in the free space. But if we put them into such a small, narrow, confined space, crystallography is going to be different from the bulk structure. So this is interesting, the science there. Okay, so then I come to the program. And the single carbon nanotube. And then we can have these C60 inside if you do the proper treatment. Carbon nanotubes, as grown carbon nanotubes, are closed. So no way to get into this. So we have to cut this by oxidation or some other technique. So through this the opening, we can put the many things. So I show you several examples of this. Very interesting. Okay, so this is known for some years. Then the fluorine pages. Okay, so first one is just the imaging. This is the C80 molecule. C8 molecule is like that. And actually, these are images. Here I'm going to talk about molecular structure analysis using high resolution transmission microscopy. So we have the single carbon nanotube. Inside, we have C80 molecules. Okay, that's a peapod. And then if you look at some of them, then we have typical contrast. And this particular case, maybe you see 80s moving around. So in certain direction, the projections, you see this 1, 2, 3, 4 sort of empty area in molecule. So this is seen as white region. This is the simulations. So in this way, that region we have more carbon lattice. More means maybe 3 carbon lattice. So in this way, we can do the molecular structure analysis directly from the images.